Imagine standing in a room with almost no light at all, the kind of darkness that is genuinely rare in modern life, where no artificial light reaches the eye. Only whatever faint glow the night allows to seep in around a curtain or beneath a door. In the first moments, the experience is close to blindness. The eyes are open and straining, and they deliver nothing, a flat and featureless black that the mind keeps trying to resolve and cannot. For most people, this is where the story of human vision in darkness ends, because they reach for a switch or a phone within seconds, unwilling to sit inside the discomfort of seeing nothing. But if no artificial light arrives and none is summoned, and if the person simply waits, something begins to happen that almost no one in the industrialized world experiences anymore. Slowly, over minutes that feel much longer than they are, the darkness starts to yield. Vague shapes separate from the black. The edge of a doorway resolves. A pale rectangle that was invisible becomes a window, admitting starlight that was always there, too faint a moment ago to register, and now just barely enough. The room that offered nothing begins, quietly, and without any change in the light, to become visible. What has happened in those minutes is one of the most dramatic shifts the human body is capable of, and it is almost entirely hidden from us because we so rarely allow it to occur. The sensitivity of the eye has not changed slightly. It has increased by an enormous factor, by orders of magnitude, transforming a system that registered nothing into one capable of detecting light, so faint that it approaches the smallest quantity light can be divided into. This process is called dark adaptation, and it represents the body opening a capacity that remains fully intact, fully functional, and fully available, and that the modern world has rendered nearly obsolete, not by damaging it but by ensuring it is almost never needed. The door the title gestures toward is real, and it is more concrete and more understood than the phrasing suggests. The body still opens it. We have simply built a world in which we almost never wait in the dark long enough to notice. It is worth saying clearly that the door does not open onto absolute blackness. It opens whenever there is some faint light to be gathered, the trace of stars or moon or distant glow that a daylight eye cannot use but a fully adapted one can. To understand what is being opened, it helps to recognize that the human eye does not contain one visual system but two, layered together in the same retina and suited to entirely different conditions. The retina is lined with two kinds of light-sensitive cells. The cones, concentrated densely at the center of vision, are the cells of daylight. They give us sharp detail and the full range of color, and they require a generous supply of light to work, which is why color and fine detail drain out of the world as darkness falls. The rods are something else entirely. They vastly outnumber the cones, spread across the periphery of the retina, and they are built not for detail or color, but for sensitivity, for ringing a signal out of the smallest trace of light available. In bright conditions, the rods are effectively saturated and contribute little. The cones carry the day. But as light fades, the balance shifts, and in true darkness, it is the rods, almost alone, that determine what we can see. The transition between these two systems is not instantaneous, and that delay is the reason dark adaptation takes time rather than happening at once. The slowness has a chemical cause that is worth describing precisely because it explains both the experience and its limits. Inside the rod sits a light-sensitive pigment, a molecule that changes shape when it absorbs light and, in doing so, triggers the nerve signal that the brain interprets as vision. When the eye is exposed to bright light, enormous quantities of this pigment are broken down, or bleached faster than they can be rebuilt, which is part of why the rods are nearly useless in daylight, and why stepping from bright sun into a dim room leaves us briefly blind. Rebuilding the pigment is a slow process. It happens continuously in darkness, molecule by molecule, and only when the supply has been substantially restored can the rods reach their full sensitivity. This is why dark adaptation unfolds over tens of minutes rather than seconds, and why it proceeds in two distinct stages, the cones adapting first over the opening minutes, and then handing off to the rods, whose recovery continues for half an hour or more before vision in darkness reaches its peak. The pale window that emerged after a few minutes is only the beginning. The full opening of the door takes the better part of an hour of uninterrupted dark, and a single bright flash can undo much of it in an instant, sending the rods back toward the bleached state and forcing the slow recovery to begin again. The end point of that recovery is genuinely astonishing, and it is grounded in careful experiment rather than enthusiasm. In classic studies of human vision conducted in the middle of the 20th century, researchers established that a fully dark adapted eye can respond to a remarkably small amount of light arriving at the cornea, so little that only a handful of particles may actually be absorbed by the rods themselves. Placing the system close to the absolute physical limit of what is possible, near the point where individual rods are registering individual photons, there is little room for a biological detector to do better, because the rods are operating so near the single photon limit, and below that threshold there is simply less and less left to detect. This is the capacity that sits dormant behind our eyes through every illuminated evening, the reason a dark adapted person, on a clear, moonless night far from any city, can see the landscape laid out in shades of gray under nothing but starlight, can make out the shapes of hills and trees and the pale ribbon of a path, can watch the faint band of the Milky Way arch overhead with a clarity that residents of lit cities often refuse to believe is real. The eye that seemed useless in the first dark seconds was not failing. It was waiting for the door to open, but the vision that emerges through that door is strange, and describing it honestly is part of resisting the romance the title invites. Rod vision is not simply a dimmer version of daytime sight. It is a different kind of seeing, with its own peculiar rules. Because all the rods share a single type of pigment, they cannot distinguish color, and so the adapted night world arrives in monochrome, a landscape of grays with the hues stripped away. Detail is poor because the rods are wired together in a way that trades sharpness for sensitivity, pooling their signals to catch faint light at the cost of fine resolution. And there is a stranger consequence still. The very center of our vision, the small patch we instinctively aim at anything we want to examine, is packed almost entirely with cones and contains very few rods. In daylight, this center is our sharpest, most detailed sight. In darkness, it becomes a blind spot. A faint star, looked at directly, can vanish, and then reappear the moment the gaze is shifted slightly to the side, allowing its light to fall on the rich periphery. Astronomers and night sailors learn this deliberately, training themselves to look slightly away from what they most want to see. A technique that inverts the ordinary logic of attention, and that feels, the first time it works, almost like a trick the eye is playing. The same physiology explains a practice that can seem mysterious until its cause is understood: the use of red light by those who must preserve their night vision while still seeing well enough to work. Submarine crews, astronomers, and military observers have long worked under red illumination, and the reason lies directly in the chemistry of the rods. The rod pigment is relatively insensitive to long wavelength red light, far less affected by it than by the blues and greens, to which it responds most strongly. Dim red light therefore affects the rods far less than blue, green light, helping preserve dark adaptation when it is used carefully, allowing the cones to provide just enough vision to read an instrument or a chart without slamming the door that took half an hour to open. It is not magic, and bright red light or prolonged exposure can still interfere. The protection depends on keeping the light dim. But used with care, it is a way of keeping one foot in each visual world, using daytime vision for a task, while leaving the night system primed. This shift in sensitivity toward the blue-green end of the spectrum as we move into darkness has a visible consequence as well. As twilight deepens, reds fade toward black, while blues and greens retain their brightness longer, so that a red flower and green leaves that looked equally vivid at noon part ways at dusk, the flower going dark while the leaves still glow faintly. There is, woven through all of this, a dependency that connects night vision to the most basic facts of nourishment, and that grounds the whole subject in human history in a sobering way. The light-sensitive pigment in the rods is built from a molecule derived from vitamin A, and when that vitamin is in short supply, the body cannot maintain the pigment, and the rods fail before the cones do. The result is night blindness, the loss of vision in dim conditions, while daytime sight remains intact. And it is one of the oldest recognized signs of dietary deficiency, described in medical texts thousands of years old, and still a serious problem in parts of the world today. This is the unromantic underside of the door in darkness. It is not a mystical gift, but a physical system with physical requirements, one that can be quietly shut by hunger, long before the larger machinery of vision is affected, a reminder that the capacity to see at night has always been contingent on the body being adequately fed. It would be easy, having traced the elegance of this system, to slide into the familiar lament that modern life has stolen something precious from us. And there is a real loss worth naming, but it deserves to be stated carefully rather than mournfully. What artificial light has done is not to weaken our eyes, but to make the door almost irrelevant, because we have largely abolished the conditions under which it opens. A person who spends every evening in lit rooms and falls asleep beside a glowing screen, who steps outside into streetlights and walks through a city whose sky never goes fully dark, may go years without their rods ever reaching full adaptation. The capacity is intact in such a person exactly as it was in their distant ancestors. The pigment still regenerates in darkness, the rods still detect their handful of photons. The door still opens whenever genuine darkness and enough time are granted together. What has changed is that those two conditions, real darkness and uninterrupted time within it, have become some of the scarcer experiences in the developed world. The loss is not of a faculty, but of an encounter. The encounter between a fully prepared eye and a truly dark sky. And yet the romance has to be tempered from the other direction too, because the human night vision system, for all its photochemical elegance, is modest by the standards of the natural world. We are diurnal animals built for daylight, and our adaptation to darkness is real but limited. The truly nocturnal creatures we share the planet with leave us far behind. Cats and many other night hunters carry a reflective layer behind the retina that bounces light back through it for a second chance at detection, a structure we lack, which is why their eyes flash in a beam and ours do not. They devote far more of their retinas to rods, sacrifice color almost entirely, and see in darkness that would leave a dark, adapted human helpless. The door our bodies open is real, but it opens onto a dim and colorless and low-resolution world, useful for moving through a landscape lit by stars, but no match for the eyes of an animal that hunts in the dark for a living. Our ancestors navigated the night not because they had extraordinary vision, but because they had ordinary human night vision, fully exercised, combined with knowledge of the land, the use of fire, and the slow patience of people, for whom darkness was simply a fact of half their lives rather than a problem to be switched away. That, in the end, is the truth. The title circles toward without quite saying. The body has not lost the ability to see in darkness, and it has not had that ability awakened by any technique or discipline. The ability was never asleep and never absent. It is a standing feature of the human eye, a two-system design in which the night machinery waits patiently beneath the day machinery, requiring nothing more exotic than darkness and the better part of an hour to come fully online. The door is not hidden, and it is not locked. It is simply behind a wall of light that we built for reasons that were mostly good, the reasons of safety and productivity, and the human refusal to surrender our waking hours to the night. We gained a great deal by banishing the dark, and it would be dishonest to pretend otherwise. But in gaining it, we quietly stopped opening a door that remains, in every one of us, perfectly functional, so that the experience of watching a black and useless field of vision slowly fill with the gray shapes of a starlit world has become something many people may go years without, not because their bodies cannot do it, but because they will never sit still in darkness long enough to let it happen. The capacity outlasts the occasion for it. The door still opens. We have mostly stopped walking up to it.